Hello wonderful person, this is Anton, and today we're going to be discussing a relatively recent mystery of something referred to as the Amaterasu particle. Something we discussed back in 2023, and something that represented one of the most energetic particles ever detected anywhere. And back then this was referred to as the another oh my god particle. The super famous event detected back in 1991, that represented something that even today is very difficult to explain. A particle containing so much energy that it was actually impossible to explain where it came from. Here the energy was about 40 million times higher than anything we ever produced on Earth using particle accelerators. Or I guess in more layman terms, the energy was equivalent to a baseball traveling at approximately 100 km per hour or 63 miles per hour. Except that this was just one tiny particle. And well, after approximately 3 decades, we seem to have another such event. But this unusual event, discovered in the desert of Utah, actually left a lot more questions because in this case, it even challenged our understanding of how we think universe works. And so let's talk about this event and recent discoveries, and of course the potential explanation a little bit more. But I guess let's first go through some details and some basics, just so that we're all on the same page. First, here we're not talking about radiation, we are talking about particles. Particles traveling across space, but in this case with velocities approaching the speed of light. And as you might remember from your physics class, no matter can actually travel at the speed of light, but as they do move faster and faster, their energy starts to approach infinity. And so in this case, these particles usually travel at like 99.9999999% of speed of light, which is why they're so energetic. And while both the OMG particle and the Amaterasu particle had a very similar energy of several hundred eVs, or essentially here we're talking about 2 times 10 to the power of 20 electron volts. As I mentioned, this is a ridiculously powerful amount of energy and represents an actual object, such as a baseball. But unlike the OMG particle, the problem with this detection is also where it came from. Because unlike the OMG particle, when the scientists traced back the trajectory of this event, they discovered that it seems to be coming from a galactic void, or specifically the region referred to as the local void, where we kind of expect nothing. Or almost nothing, because we only know of like 6 galaxies that seem to be inside. And none of them contain massive black holes that should be capable of producing anything so powerful. And so that's essentially the main mystery. Where exactly did this come from? How was this formed? And how do we even start approaching trying to explain this very strange mystery? But turns out that there is a way to approach this without breaking any modern physics. And so to try to explain this, we need to go through some of the basic steps on how we usually detect these and how we think these particles travel across space. And so let's start with the Telescope Array project in Utah. Here this observatory consists of approximately 500 detectors spread across 700 square kilometers in a desert. And they're mostly meant to detect various particle showers. And on May 27, 2021, 23 of these detectors simultaneously triggered what's known as an air shower. Basically the production of a lot of subatomic particles, which is usually the result of some kind of a powerful particle hitting the upper atmosphere. And while this took a few months to examine, but eventually, once all of this was reconstructed, it was discovered to be super powerful. 244 exa-electron volts. Just to give you a slightly different comparison, this is the energy of a typical brick being dropped from a waist level. And yeah, that would definitely hurt your foot. And while in the world of physics, this is almost impossible, or at least currently impossible to explain. In the history of recorded science, except for this particle and the oh my god particle, nothing else comes even close. And so no actual mechanism for their formation is known to us. But the mystery in this case was of course the location or the origin. When astronomers were tracing the path of this object, they did expect to find some kind of a violent supermassive black hole or some kind of a very massive galaxy, possibly involving a quasar. Except that, as I said, it seemed to be coming from the local void. And the local void contains almost nothing. It's a vast empty region very close to the Milky Way that has a much lower density of matter and contains only 6 known galaxies. There's nothing in here that we know of that could produce anything so powerful. And so for a couple of years now, this was considered to be some kind of an unknown astrophysical phenomenon, or maybe even physics that goes beyond the current standard model, with some initial propositions involving a lot of bizarre physics, such as some kind of a magnetic monopole, or maybe even some kind of a super heavy dark matter particle. Or I guess just to rephrase this, Nobody had any idea what this was. But the approach that Nadine Bourriche and Francesca Capel took was a little bit different. They basically didn't focus on the origins, they instead decided to focus on the actual particle because it might explain to us where it came from through slightly different means. And so, for example, if this was some kind of a proton or just a stripped atom of hydrogen, it would very likely travel in a straight line and would not be affected by magnetic fields like the ones we find in various galaxies. And this would imply that its source is extremely likely inside this empty void, or maybe even beyond the void, and we just don't really see it because it's so far away. In other words, here the mystery would still remain a mystery. However, what if it wasn't a proton? What if it was actually something much more complex? For example, a much heavier nucleus, such as iron. Well, here, an iron atom would actually change things. And that's because heavier particles also have higher electric charge, which means that magnetic fields in galaxies tend to affect them a lot more. And so if Amaterasu was iron, its source could have been much farther away, with this particle potentially taking a path that was a lot more curved on the way to us. And that's because these particles are generally pushed and pulled by magnetic fields as they travel. So kind of like trying to walk in a straight line in very, very windy conditions. And that means that if this particle was an iron particle, it could have come from a lot of different locations that's not the galactic void. Which brings us to this new study from 2026. And so here scientists from the Max Planck Institute used a sophisticated statistical method referred to as approximate Bayesian computation. And they then combined this with 3D simulations of the universe's magnetic fields. And so instead of looking for just a straight line, they tried to simulate millions of possible paths that the particle could have taken. But in this case, accounting for all of the interactions with magnetic fields based on the maps we have. And the results in the study do provide us with a much better explanation. An explanation that suddenly does not break any physics. Because their simulations show that it's quite probable that this particle did not originate from the local void, but instead possibly came from one of several starburst galaxies. Here we're talking about galaxies containing starburst regions that usually produce a lot of supernova, responsible for the production of cosmic rays and also responsible for the production of very powerful magnetic fields, both of which could have, in theory, produced one of these particles. And right now, the top candidate is this, Messier 82, a galaxy 12 million light-years away from us, very famous for its intense star-forming regions and the beautiful formation you see coming from the center. This is actually not the result of the black hole, this is the result of star formation. With the other potential candidate being NGC 6946, also known as the Fireworks Galaxy, and NGC 2403, also known as Caldwell 7. And this, of course, makes a lot more sense. Basically, this study suggests that if Amaterasu started as an iron nucleus, it could have been pushed and pulled by magnetic fields that would have deflected its path just enough to make it appear as if it came from the void. But in reality, it could have come from one of these very active, well-known galaxies that do contain a lot of sources of potential cosmic rays, with at least one of them maybe just being a little bit too powerful. And so unlike previous analysis that usually focused on the straight line arrival direction, here by using these probability maps, and by combining this with magnetic field maps, the results seem to be just a little bit better. With this paper basically being a kind of a milestone for a lot of future research on these ultra-high energy cosmic rays. The concept that's still a little bit mysterious, but that hopefully in the next few years we'll finally be able to crack. And this is actually why this research is kind of important. These particles are basically kind of like the messengers of some of the most violent events in the entire universe. But exactly what type of an event this is, we're not sure. And so whether this is a star being torn apart by a black hole, or basically a tidal disruption event, or some kind of a very powerful supernova, only time will tell because we need to be able to trace these objects in order to see the actual source. And once we're able to understand these particles, it will help us understand the universe and the limits of nature just a little bit better. As a matter of fact, quite a few slightly less powerful particles have already been detected in the last few decades, and so we know these events seem to be pretty common and seem to come from various locations in the universe. But because the most powerful events are so rare, it will definitely take a while before we get more answers. Luckily, the telescopes detecting these are actually getting new upgrades, with this one, the telescope array, currently being expanded to 4 times its current size. And additional projects like the space project, referred to as Poema, will hopefully become operational soon as well, and will allow us to detect these objects directly from space through a pair of very specific satellites orbiting around the planet. But it's unlikely to launch before 2029. But at least for now, as of 2026, these are still very mysterious and very exciting detections. In this case, the Amaterasu particle reminds us that we still have so many mysteries when it comes to physics that we just cannot explain. And though at first it did seem to actually break the laws of physics by appearing out of nowhere, this recent study explains this in a slightly different and actually much more elegant way. It basically could have been just a particle whose path was affected by a lot of magnetic fields. And this is of course something that happens to a lot of different cosmic rays as they travel through the Milky Way. But as we get better at tracing these events, and as we detect more and more, we might be able to finally figure out where these bizarre cosmic bricks that are subatomic in size seem to be coming from. For now, I'm just going to leave you with whatever we have. It's still a mystery, but it could have come from Messier 82. Thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining the channel membership that grants you early access. You can also support this channel by buying the 104% t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.